Hey everyone, welcome back again. Now let's see the truth table for disjunction. So disjunction is read as or. If P is a statement, Q is a statement, we use the symbol, this symbol, and for disjunction, and it will be read as or. For example, now let's see a couple of examples. Say now I am saying I am dead or alive. So let's see this here. P is the statement, we'll say that I am dead, and Q is another statement, we'll say that I am alive. Alright, so let's see writing another thing. Say 5 greater than 2 or 2 greater than 5. Okay, so P is a statement 5 greater than 2, and let's see Q is another statement 2 greater than 5. Alright. Or okay, so here for the disjunction we can see that if one of the value is true, we can say that the compound statement value will be true. Say for example here I am dead or alive. If you now think that as a single statement, what do you think? Yes, I will be either dead or I will be alive. So as a single statement, I can say that this statement is true. If I am dead, so if I am not dead, the value here will be false. If I am alive, the value here will be true. Okay, I will be either dead or alive. It's true. So that means the value will be true. Now 5 greater than 2, 2 greater than 5. Both cannot be actually at the same time true. Okay, so let's see 5 greater than 2, it's true. Okay, and 2 greater than 5, that's false. All right, but if I now say as a single statement, okay, if I now say as a single statement either 5 greater than 2 or 2 greater than 5, yes, one of them is greater than another. Okay, so as 5 greater than 2, so the whole statement means true. So for disjunction and for or statement, okay, so for or statement in English word it will be read as a or. If one of the statement value is true, the value of the statement will be true. If one of the input statement is true, the value of the compound statement or statement will be true. Okay, so let's write down the truth table. So here we are going to write down the input statement P and Q, and first we are going to list all the combination. So with if P is true, with true, Q can be either true or false. Okay, now if P is false, Q can be either true or false. All right, if one of them P and Q is true, P or Q will be true. Okay, so here both are true, so true. Here P is true, true. Here Q is true, true. And here both is false, so it will be false. Let's see one example where both can be false. Okay, say I'm saying that 1 greater than 5 or 2 greater than 5. Okay, none of them is actually true, both is false, and I can say that yeah, 1 greater than 5, 2 or 2 greater than 5. So both is actually false, none of them is true. So as a single statement I am going to tell that the statement is false. Okay, so now let's see another compound statement known as implication. Okay, so we are going to use this symbol implication like this, implication, and we write it like as a P implies Q. Okay, so also in English word it will be read as uh, if P then Q. Okay, so it will be read as like if P then Q, or it can be also read as if P implies Q. Okay, so P true, so therefore Q will be true, or P only if Q. Okay, or we can say also like Q follows from P. All right, so there are a couple of other things we can say that, but let's see for now, let's see a couple of examples from them. So let's see, I'm saying that if it is sunny, school opens. Okay, now I'm saying that if the weather is sunny, then school will open. Okay, so school will open only if school will open if it is sunny. So I can think about like that, this statement is P and another statement Q means school opens. Okay, so then I can it's an example of implication, means P implies Q. So it is sunny, it means that school opens. Okay, so here in the implication, P is known as hypothesis and Q is known as conclusion. So I'm saying that if P is true, all right, if it is sunny, if P is true, then Q will be true. Okay, if P is true, if the hypothesis is true, then the conclusion will be true. So depending on the, we can find the value of the Q depending on the value of P. I'm saying that, say if it is sunny, school opens. So look at the sun. If you can find out it is sunny, then you will know that Q is true. Okay, something some other example, let's see, if 5 is greater than 2, okay, then 6 greater than 2. Okay, 6 greater than 5, so that's why I am like giving a hypothesis like that. Say this is P and I'm saying this is my hypothesis. Okay, and I'm saying this is my conclusion. Or I can say that, let's see, if x greater than 2, then x plus 1 greater than 2. Okay, and let's say x is some positive integer number. Okay, so something like that. So if we write something like that, where the value of Q depends on the value of P, Q will be true only if P is true. Okay, Q will be true only Q will be true if P is true, then we can say that P implies Q. Okay, all right, so we can read it like that, say if P is true, then Q is true, or we can say that if P then Q. For example, like if it is sunny, school opens. School opens sorry, if it is sunny, or like sunny weather implies school is open. Okay, like that. So, or we can say that it is sunny, so therefore school opens. Okay, all right, there so let's see, think about the truth table of P implies Q. Okay, so let's think about the truth table of P implies Q. So we have P, we have Q, and the compound statement is P implies Q. So let's see, P is true, Q is true, P is true, Q is false, Q is false, Q is true, P is false, Q is false. Alright. Now if P is true, Q will be true. That is the meaning of our implication. Okay. So if P is true, Q will be true. So that is the meaning of our implication. Means the value of P implies Q is true. Okay. Now let's find out that P is true but Q is false. Then what happens? This is something like that. The weather is sunny but school didn't open. Okay, but our implication was sunny implies school open. Okay, but we found out sometime that the weather is sunny but school didn't open. Okay, then what happens? Means that this implication, the value of the implication becomes false. It cannot happen actually. Based on the implication statement, if P is true, Q should be true. Okay, but if we find out that P is true but Q is false, that means the value of this implication is false. Alright, now let's see if the value of P is false. Based on this implication, we only say that if P is true, Q is true. Okay, if P is true, Q is true. But what happens if P is false? Then what? Q is true or false? This implication P implies Q actually doesn't tell us about that. What happens if P is false? We know that the school will be open if this is a sunny weather. But if this is a foggy weather, what will happen? School will be closed. This implication actually doesn't clearly specify that. Okay, we do not know what happens if P is false. Okay, now if we do not know that what will happen if P is false, then what will happen to Q, either true or false? If we do not know that, in that case we are going to just tell that they are true. Okay, they are also known as like the thing is that we do not know that Q will be false if P is false. Okay, so that's why we are going to tell that the value of this implication will be true. Okay, they are also known as like vaciously true. So we do not actually exactly know, because we do not have idea. From this implication we do not have idea what will happen if P is false. So that's why we will just say that the value of the implication is true. Okay, so the truth table of P implies Q will be, if P is true and Q is false, then the value of P implies Q is false. Other than that, every value is true. Okay.